Okay, so now the one that gives everybody the trouble. I'm not going to go into the whole fill in the blank squares. I'm just going to show you how it works, just so you can see that it does work. So, what did I do with, oh, there it is. So, we're going to draw a combination circuit. Okay, so again, L1 and neutral. Our source voltage, 120 volts. Our first conductor comes across. Our normally open single pole, single throw switch comes out. Comes to our first light. Also comes out. Goes to our second light. They come out and rejoin each other. These are in parallel. These two lights are in parallel. They are now in series with our third and I return the neutral. Combination circuit. Not exactly what's out of the book, out of your binder, but this is how we're going to show you here on our project board. Our switch, our source, our parallel circuit, and our series circuit. This parallel circuit is in series with this single load. So let's build this. First, our power source, L1, to our switch. From our switch to our first load. From there, remember, our first two are in parallel. So they both need their own source of voltage. This is being fed in here, and this is coming over to here before it goes into that load. When it comes out, comes in, goes through, comes out, comes in, goes through, comes out, and rejoins here. These are now in parallel. L1 through our switch, they split. One goes to one load, one goes to the other. They come out and rejoin each other. L1 through the switch, one goes in through one load, one comes out to the other load. They come out and rejoin each other right here. From there, we are now going to wire this parallel circuit in series with this load. We have now wired from where these come together to the line side of that load. From here to here. Now, we are going to take from the other side of our last load back to neutral. We've come out of the other side of our load and back to neutral. We will now apply voltage. Let's make sure our power is off. All right. We have 120 volts at our meter. By throwing this switch, we will energize this circuit. As you can see, the final load in that series is much brighter than the other two loads. I'm hoping you can see this. The total amp draw across the entire circuit should be 120 volts. Let me double check on that. Right. $120 volts for the entire circuit. But individually, these two are 40 volts. But because they're splitting the voltage, well, let's back up. This here is using 80 volts, roughly. So what's left has to be used on this, but because they're in series, parallel, they're using the same amount of voltage as if they were in all by themselves. Each load is using roughly 40 volts. Together, they're still using roughly 40 volts. 40 volts and 80 volts add up to 120 volts, which is our source voltage. And that's a complex or a combination circuit. It's not too often you're going to come into contact with one of these. The only reason I did this is so it would make that last worksheet a little bit clearer.